Hello everyone. So today let's solve the problem roads in Berland. Right. So this was asked in the Codeforces beta round 25 for the division 2 only. This is rated for the division 2 only. Right. So yeah, you can just go through the question. It's simple to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So this is one of the easy questions. Man, again, I want to tell you one thing that we are done with the flow based problems, right? Network flow based graph problems. We have solved around 3 problems. That's more than enough, man. Yeah. So that was extremely difficult ones actually. One that was rated more than actually 2500. Mostly 2 problems are more than 3000. So one problem is solved around 2100. That was rated. All the difficult ones actually. It's fine. So we have solved. We know mostly we solved that one using the BFS along with the Q, and one we implemented 2 problems. This one we implemented the Dinix algorithm. We didn't get a chance to implement the push relabel, so we'll be implementing the same within this one. What do we call? Uh, Within some contest or something. Yeah, we don't have to worry. We don't have to worry that much, right? So there are many flow algorithms that we can implement, right? So we can just go with a this one. Uh, what do we call? Dinix was one of the things that we got chance to implement. So I just implemented Dinix algorithm. So most of the flow algorithm you can just implement this one. You can just solve that one using the Dinix algorithm. In my opinion, you can just go with the Dinix algorithm or push tree level algorithm. Sometimes that can be solved easily with the flow propagation itself, along with the this one BFS and the Q. Right. So now let's do one thing. Let's move on with certain problems that can be solved with a Floyd-Warshall. So very recently we had discussed the Floyd-Warshall algorithm as well, right? So if you don't know Floyd-Warshall algorithm, you'll not be able to understand what we are solving, right? So you can understand the question, but you'll not understand the implementation. You can just understand even within the approach. When I say Floyd-Warshall, I'll not be explaining the entire algo. So we'll be going with a certain things, how to solve the problem, and we'll be solving the implementation. You'll get to know only if you know the Floyd-Warshall algorithm, right? So you can just go to the graph-based algorithm playlist and you can just check the Floyd-Warshall algorithm. There are many important algorithms. So you can just go through the Dijkstra, you can just go through the Billman-Ford, you can just go through the Floyd-Warshall, Johnson, uh, yeah, and you can just go through the this one as well, Dinix algorithm, push relabel, and Kahan's algorithm for the topological sorting as well. That is one of the important algorithms as well. And you can just go through this one. Same thing, strongly connected components, Kosaraju's SCC algorithm as well. So there, those kind of algorithms you have to know, because you'll get a chance to implement those kind of algorithms within the contest, or while practicing also you have to practice that one. You'll get many chances to this one, what do we call, implement those kind of algorithms, right? That will be fun actually. That will be fun, and you'll learn many things while you implement certain things. You'll really feel good about yourself, right? So for that, you have to know the algorithm at any cost, or else you'll not uh, come to know the entire solution. You'll just know what we did, but you'll not, if you don't know the algorithm itself, how do you understand the implementation part? Yeah. So that I insist you to go through the this one, graph-based algorithms. There are certain, I have only we have only discussed this one. What do we call, important algorithms itself, right? So around 20 algorithms we have discussed actually, 19 to be this one, if I want to correctly say. It's exact 19 actually, exact number 19 basically. Yeah, you can just go through some of the algorithms. If you even if you want to leave certain algorithms, you can, but go through some of the algorithms that are very, very important. You'll get the chance to implement those algorithms. Yeah, that's what I wanted to say. Now let's move on with the question part. So there are n cities with a given matrix, right? So there are n cities here with a given matrix of pairwise shorted distance, pairwise short or shortest distance, right? So this is symmetric and zero diagonal. Just remember this. This is symmetric and the zero diagonal. So the government will add k new undirected roads. The government will add k new this one. What do we call? Government will add k new undirected roads. Undirected roads. This is fine. So given endpoints and length, the endpoints and the length will be given. So after each road is added, nothing but in this case permanently, after each road is added, we have to output, after each road is added, we have to output, what we need to output, the sum of shortest distances, right? Sum of this one, shortest distances. Sum of shortest distances, right? I'll just write here distances actually. Yeah, the sum of shortest distances between all unordered pair of cities. All unordered pair of cities, right? So this is fine, I believe. Yep. We have to use the provided distances to update the shortest paths efficiently. So they have strictly mentioned in the question. We have to use the provided distances to update the shortest paths efficiently. So this is it for the question. So let me read the question out loud. Just listen to this carefully, man. There are n cities. Yeah, there are n cities with a given matrix of pairwise shortest distances, right? Pairwise shortest distances, the pairwise is symmetric along with a zero diagonal, right? So just remember this. The government will add k new undirected roads, yeah, k new undirected roads given endpoints and length. After each road is added permanently, we have to output the sum of shortest distances between all unordered pairs of cities. Yeah, all unordered pairs of cities. Yep. So we have to use the provided distances to update the shortest paths efficiently. Yep. So this is the question actually. This is the question, right? So let me delete this one second. Yeah. Let me come to the input output part. So this is n. This is nothing but n here. N we have been given two. So these are basically what do we call? This is a matrix actually. 0, 5, 5, 0. Yeah. So this is nothing but 0, 0. It starts with 0, 0. Basically 0, 0, 0, 1, 1, 0, 1, 1. So this is basically 2 into 2 matrix. Yeah. Or the grid that you can consider. 0, 5, 5, 0. Yep. Next one we have been given. So this is nothing but the k accordingly with the question that we discussed, right? This is nothing but the k. Finally, 1, 2, 3 is nothing but the road 1, 2 with the length 3. So this one, road 1 and 2 with the length 3. With the length equals 3. Yeah. So again, so this is nothing but the n. We have 2. So 2 into 2 matrix, right? So this indicates that we have 2 into 2 matrix 0, 5, 0, and this one. What do we call? Uh, 5 0 0 5 and 5 0. So this one 0 comma 0 0 comma. This is fine, man. Yeah, 2 into 2 matrix. They have mentioned n equals to 2, 2 into 2 matrix 0 5 5 0. 1 is nothing but the k here. We are having 1 and 2, road 1 and 2 with a this one length 3 actually. Yeah, this is it for the input output. The output that we need to get here is 3, meaning the sum of the shortest distances between all the unordered pairs of cities is 3 here, right? 3. So this is it for the input output basically. Yeah. So now we have the idea on the question. Yeah, and also we have the idea on the input output as well. Let's do one thing. Let's quickly discuss the approach, right? So as I've said, we will be going with a this one dynamic fluid Warshall, or let me write here fluid Warshall. So we'll be making use of the fluid Warshall approach here, or the fluid Warshall algorithm, right? So yeah, the first step here would be, let's consider the same first example for the approach, right? So that you can implement the same thing, or you can just try it out the same thing um, by considering the example 2 or the input 2. So let's move on with the approach part. So initially distance between city 1 and city 2 is 5. City 1 and city 2 is 5. So this one, initially the distance between city 1 and city 2 is 5 actually. Initially the distance between city 1 and city 2 is 5 actually, right? So this is fine. This is the first step. We know this one, right? Sum of unordered pairs, sum of unordered pairs here. So this one is equivalent to 5. This is fine. Let's move on with the second point. This we know. This we know this one by the input. We have considered first example, right? For the input, this is fine. So we will be adding road 1 to 2. So we have road 1 to 2 with the length 3, right? So we will be adding road 1 to 2. Yeah, I can just write it in this way. We will be adding road 1 to 2 with the length 3. With the length 3. I'll just write it in this way. Now, distance 1 comma 2 becomes min of distance 1 comma 2 becomes, so this one I can just write it in this way. Minimum of old 5, the value that we got 5, old 5 comma new direction. So this one 3, this one length 3 we have been given, right? So this one will be new direction, this one new direct 3. I can just write it on this direction 3. So this one minimum we are considering, the value we have got here is 5 and 3. Min of 5 and 3 will be 3, right? So we will be going with the 3, value 3. So this is fine, I believe. Simple, very simple to understand. Let's move on with the third one. Since we have only one cities, so two cities, sorry. Since we have only two cities, the matrix update finishes here, and the sum of the unordered pairs is 3, the previously that we got. We have only two cities, yeah. Since we have only two cities, the matrix update finishes, and the sum of unordered pairs, right? So let me write here sum of unordered pairs, right? So we need to calculate sum of unordered pairs itself. Sum of unordered pairs will be 3, right? So in this case, we have to output after the first and only, right? So this one only output after the first addition, that is equivalent to 3. Nothing but here out we need to output 4 here in this case, right? Output sorry, output equals 3, right? Sorry, we need to output 3 here in this case. So this is simple one. Try to implement the same thing for the example 2 man. Yeah, this is very simple actually. I wouldn't lie. So this is medium to this one difficult based question. So you can just do it easily. This is fine. Yep. Now, so we just have to output the first addition, nothing but 3 here. So what is the general idea here? So let's consider the same thing in the directly while we write the code itself. So this is the idea, or this is what we will be doing, right? So this is what we'll be doing. So the same thing will be implementing in the form of code, or articulating this one in the form of code. Yeah. So this is fine, I believe. So now as we have idea on the question, so the output that we got here is 3, right? So which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be time complexity here? The time complexity would lead to big of k into n square. So why it is big of k into n square here? Because see, so we will be going with the inner pair updates that cost big of n square per new road. Also, note one thing here, each pair update does big of one work, right? So overall, we have to consider big of k into n square, right? For that time complexity. This is fine, I believe. So what will be the space complexity here? Space complexity would lead to big of n square as well here. So just to store the distance matrix A, right? So overall space complexity would lead to big of n square. The time complexity and the space complexity for the code that we'll be writing in the future would be big of k into n square and big of n square respectively. Now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code, right? So we'll be making use of the different, this one, fast input and output. So let me import input output package here. Also, we'll be making use of different utilities. So I'll just go with java.util dot, right? So this is fine. Now let's go with public class. So this is fine. Let me go with main. Main method. Yeah. So I'll just give here and main. This is fine. Within the main method, what we'll be doing. So let's go with the matrix of the shortest distances. We can keep up to n less than or equal to 300 here. So this one will be static. Long. So this is fine. A equals new long of let me go with your size 305 accordingly with the constant. So this is enough actually. That's 305 and 305. This is fine. This is nothing but the matrix of the shortest distances one. Yeah, we have to assign. So sorry, we have to initialize n and k as well. N is nothing but the number of cities. K is nothing but the number of new roads. So I'll just go with static int n and k respectively. Right. So this is fine. Next, let's move on with the main method here. So let me include here throws input output exception. This is fine. Yeah, within the main method, so we have to go with certain things actually. See, buffered reader, the normal things, the buffered reader, print writer for the input output, fast input and the fast output. String tokenizer because we have to read the first line. So we will be string tokenizer will be reused actually just to pass the lines with multiple integers. We know this, right? Next, we have to read the number of cities first, and they have given in the question, right? So this one as well, too. So let's do that first. So I'll just come here. Let me paste this one over here. Oh yeah. So this one, as I've said, buffer data for the fast input, print data for the fast output, and string tokenizer to read the first line. And this one, we are just passing this one in. Nothing but this one, the first line, number of cities actually. Yeah, this is fine, man. Yep. Now let's do one thing. I'll just come out. Let's move on with the further things. So we have to read the n into n short distances matrix, right? Shortest distance matrix, sorry. So let's move on with the iteration part after the initialization. So this one will be for int I equals 0, I less than n, I plus plus. So this is fine. So within the for loop, first let's do one thing. Let's pass the ith row. So this one string tokenizer equals new string tokenizer of buffered reader dot read line. So this is fine. Buffered reader dot read line. This is fine. Yep. Why I have mentioned this one twice, man? 1 second. Yep. This is fine. Now let's move on with one more for loop here. This one will be j equals 0, j less than. We have to go with n. So within this for loop, all we have to do is we have to store the distance d of ij. So I'll just go with here a of I j. This one let me assign this one to long dot. Instead of parseInt, I'll just go with a parse long, right? So as I've considered long here. So this one will be string tokenizer dot next token. Next token we haven't made use of. Okay. Now, okay, this is fine. Next string tokenizer dot next token. This is fine. Let me come out of this one entirely. Now, let's go with the number of planned roads, man. So this one, k, they have given in the this one. We have to consider this one as well, right? K equals 1. Number of planned roads is 1 here. So this one, let me copy the same. Oh, we haven't written the int. So let me write this one once. So we can use this one later as well. The same line. This one will be parse int actually not long as we have considered int. So buffered reader dot read line. Buffered reader dot read line. So this is fine. Now let's go with a for loop. So this one will be for t equals 0, t less than k. So we are just moving on with the iteration part. So within the for loop, let's do one thing. So this one, let me copy the same thing. Or so let me copy this one. Yeah, this one we need here. So let me copy the same thing and paste it over. Yeah. So this is fine. Now we have to convert to zero-based index, right? So this one u, v, and w actually, and nothing but node u, node v, or edge u to v, and w, right? So these three things we have to consider. So I'll just go with here this thing k equals something we have given, right? So we have to mention, we have already considered k, so I have given directly k here. So for these three things, for the nodes u, v, and weight w, we have to mention int actually. So this is fine. Int, I'll just go with the u. Let me copy paste the same thing for v and w, for the node v and weight w, right? So this is fine. Let me go with v, and also let me go with w. So this is fine, I believe. Yep. So we're just converting to zero based. So I have to use here instead of the buffer data dot read line. So let me make use of the string tokenizer dot next token here. We have to go with the string tokenizer. We have to read, right? So this is fine. Just give me a second here. This string tokenizer, this is fine for this actually. Let me paste it over here as well. So let me paste it over here as well. Yep. Now we are done with this part. Last one is nothing but the length of the neuron. Yep. UVW. So this is fine. Yep. What shall we do further? Just give me a second here. So this one I have to give -1. Sorry, not for this one. U for the node or for the vertex. This one U and V. Give -1 because we are just converting this one to the zero-based index, right? So we are just converting both U and V for the zero-based index, right? So this is fine. Now let's move on with the further things. So let's move on with the main Floyd Warshall thing, right? So after adding road u comma v with the weight w, let's try to relax all the pairs, right? Nothing but I comma j we can consider, right? So we'll be making use of the Floyd Warshall. So I'll just initialize this one sum to 0 initially. So let me go with the two for loops here. So this one will be int equals 0, I less than n. So this will be I plus plus. So again, one more for loop for int j equals 0, j less than n, and j plus plus. So this is fine. Yeah, so within the this one loop actually, what we have to do within the for loop. So the first thing is we have to try two new possible routes that use the new edge ones. So I can just write in this way. Let me show you this one. When I say two new possible routes, so I can just use this one. First one is I to U and U to V and V to J. This is one of them. And the second one, so this one has to be I to V, V to U. Sorry, yeah, I to V, V to U, and then this one U to J. The only thing is a replacement of this one from U to V and from here V to U, right? So these are the two new possible, or these are the two new possible routes that use the new edge exactly once, right? So we have to articulate the same thing in the form of code now. Let me delete this one. So how can we write this one in the form of code? So I'll just consider here long. So this is alternative one, alt one, whatever I have used, alternative one, two alternatives we have, right? So I'll just go with a of I, u, this one plus w plus a of this one, v and j, a of v and j, right? So this is fine. Next, alternative 2. So this one equivalent to a of this one, what do we call? I, v plus w plus this one, a of u as well as the j, a of u as well as the j. This is distance via I to u plus new edge of u comma v, along with distance via I to v plus new edge of v comma u, right? Plus v to j and plus u to j respectively, right? For the alternative 1 and alternative 2. So that's what we have. Now let's do one thing. Let's update the a of ij if either alternative is better, any one of them, right? So let's update a of ij if either of the alternatives are better, or if either alternative is better, right? So I'll just go with if alternative 1 is less than a of ij, less than a of ij, or alternative 2. So this one, if it is less than a of ij, if it is less than a of ij, then what we will do? Oh, so let me go with a of ij equal to math dot min of a of I, math dot min of a of ij, comma math dot min of, let me pass alternative 1 as well as alternative 2. So this is fine, I believe. Yep. So let me come out of this one entirely. So now let's accumulate. Accumulate in the sense we sum all the entries. We will divide by 2 later, right? So I'll just keep here sum equals sum plus a of I, say sum equals sum plus a of ij, right? So this is fine. Let me come out of this one entirely. So yeah, let's divide by 2 because matrix is symmetric. Yeah, so I'll just go with out dot println here. Out dot print ln is not required. Out dot print. So we have to go with sum by 2, f of v by 2, right? Sorry, not f of v by 2, sum by 2 actually. Sorry, I got confused. Sorry, this one we have to leave the space as well. Yeah, we are just divide. We are just dividing by 2 because matrix is symmetric right here. So this is fine. Now let me come out of this one entirely. We are done with the code. All we have to do is we have to ensure the output is printed. So let's make use of the out.finish here, or you can just go with out.close as well. Both works, right? So this is fine. We are done with the coding part, man. This is it for the code. Now, before checking the code with the different inputs or the examples, let me copy paste the signature starter template. Just give me a second here. I'll just paste this one over here. Let me come to the question. Let me copy this. The output that I need to get here is 3. Let's check the same. Read line. This L has to be capital here. Sorry, line number 39, right? So I'll just come to line number 39 here. Just change this one to L. This is fine. Let me run this one. Yeah, we are getting the output 3. This is fine. Yep. Now, let me copy this one. The output that I need to get here is 17 and 12. Right, so let's check the same. So yeah, we are getting the output 17 and 12 respectively. So let me copy this one entirely. Let me come here. Let me hit the submit button. The submission part, let me paste the code and let me hit the submit button again. So I hope this works for all the test cases. Let's see. Right. I hope this works for all the test cases, man. Let's see. So here you can clearly see, man, the verdict that we got here is accepted, right? So whatever the code that we have written works absolutely correct for all the test cases, right? So we have went with the this one dynamic this one Floyd Warshall method to solve this particular problem, or the modified this one Floyd Warshall method just to solve this particular problem, right? So you should be knowing the Floyd Warshall algo. If you don't know it, you'll not be able to implement one. Again, I'm telling you can just go through the graph-based algorithms playlist. You'll find certain important algorithms there, including the this one, Floyd Warshall. So to find the shortest distances, you can make use of any algorithms, right? There are so many algorithms. You can just go with a Floyd Warshall. You can just go with many Bellman Ford. You can just go with this one, Johnson's. You can just go with a Dijkstra's, right? If only positive, we are considering only positive edges, yeah. So we mostly prefer actually a Dijkstra because it is faster and it uses the a heap or the priority queue, right? So that's very fast comparatively to the other one, other algorithms basically. So this is fine, I believe. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.